Wave function is of a Greek letter called psi. The wave function is probabilistic and indeterminate. The wave function represents all possible states of a quantum system, along with the probability of the system. According to the Copenhagen Interpretation, when scientists make a measurement of a particle, the particle will be apparent in one of the many states it was in before the measurement. The wave function also expresses a wave-particle duality, where particles can be described as waves as well as particles. When trying to observe a probabilistic wave, the act of observation will thwart your attempt. The complementary concept is a central idea of the Copenhagen Interpretation, which includes wave-particle duality, and the wave function collapse is linked to the act of making a measurement. When laboratory equipment makes a measurement of the atom, the wave function will collapse into one state. The uncertainty principle by Heisenberg claims that it is impossible to determine pairs of complementary variables, such as velocity and momentum, of a particle. It is as if there is a cap imposed on how position and momentum can be measured. P represents the momentum of the particle and x represents the position. The more precise we know one of these dynamical variables, the less precise we know the other. Transitions are also within the central ideas of the Copenhagen Interpretation. During excitation, an electron will transition from ground state to the first energy level. The idea is that the electron is not at any definite place between its start and end point, almost as if it disappears from the ground state orbit and reappears at the first energy level orbit. This is the time-independent Schrödinger equation, and it represents the changes over time of a quantum system, and it predicts the future behavior of the system. E represents the total energy of the particle, and V represents the potential energy.